All right, so we're going to be talking about Phoenix, which is an Elixir web framework that I started 2.5 weeks ago. So it's very young, but I have some ambitious goals with it, and I've got a decent start on a router, and eventually I'd like to see this replace all of my current Rails development, long term. So a couple goals for the framework is to one, give me the productivity that Rails does, but in a way that I can deploy an app on 10 machines, but write code against one machine. So I want to have a focus on fault tolerance and distributed applications kind of at the base. And Elixir is extremely well suited to that, it turns out. And I also want to focus on building real-time applications. So being able to do things like WebSockets at the core of the framework are things I can't do in Ruby currently. So my goals are a lot of web scale type words, but I truly think that Elixir is super well suited for a highly performant, highly productive, fault tolerant, distributed web framework. And Ryan and I actually did a workshop where we had 30 people connected running the same program. So these kind of distributed ideas are baked into the language, and I'd like to exploit them for high productivity and awesomeness. So mainly what we're going to be going over today is the Phoenix router, which is just about the only thing that's implemented currently. So you can define routes and have them map to controllers and call a controller action. You can render text, JSON or HTML, but there's no view layer currently. So you kind of have to bring your own view layer if you want to do that. So we'll hop into an example right away. If you're coming from Rails, this will look very familiar. The goal is not to just replicate Rails in Elixir, but I think a lot of the conventions are super great, so we want to borrow some ideas where they make sense. We're also looking at the Django's router for a couple ideas, as well as Clojure has a ring framework for doing like middleware type actions. So we're trying to take some ideas from a few different frameworks and see what works. But at least for the routing layer, this should look similar to Rails, and the conventions will be similar to what Rails router is doing. So for example, if we want to route to a pages controller, we can just say get to pages and then a named parameter page, and that will route to the pages controller show action. And similar to Rails, we can actually cast that as a named route. So I can say as page here, and that will generate a route helper that will help me generate this string route pattern that I give it. That way, we don't litter the code base with hard-coded strings that may change in the future. And we'll see an example of how that works in a moment. The biggest thing to take away from this router and the way that the router is actually mapping is that it's happening all at compile time, and everything you see here is compiling to functions. So we're letting the virtual machine do all of the work, actually matching a request from the WebDriver to a controller action. I know the idea of doing this, Jose Valim, I think, did this first in the Dynamo framework. But he benchmarked, I think he added like hundreds of routes into like a Node Express framework application and a Rails app. And the app ended up spending about 30% of his time just route matching. Because what a typical framework would do is they'll build out some kind of hash or map, start at the top of your route definitions to say, does the request match this regex? No. And then it would keep on going down the chain until it matched a route. What we're doing, we're exploiting the virtual machine pattern matching engine that's been optimized for a couple decades, and we're letting it do all the work. So our goal is that when the router is compiled, it's just going to have a bunch of function definitions that are all pattern matching our patterns that we give it. So to show you an example of that, when I say get is a macro, it's actually just going to generate a function for me. So if I hop into the Phoenix router, the router mapper, then gets mad. So to call this macro get, which ultimately, if I say get, post, put, patch, delete, those are all macros that all proxy to an add route function. And the add route function is going to end up doing a tiny bit of code generation. So an at routes module attribute is basically going to accumulate a bunch of tuples with just the parameters that we have passed in. And if we hop up to where, let's try to find that. Go up to the top here. So when you say use Phoenix router, the very first thing it's going to do is register an attribute at compile time called routes. And when we say accumulate true, it's going to say anytime during compile time that you reference this route to set it, it's going to accumulate a history of changes. So within our add route, anytime we say at routes here and give it a tuple, it's going to, during compile time, accumulate that in a list of changes each time we call that. So that's just during compile time. It's going to, every time you call it get, post, put, delete, it's going to accumulate all those arguments. And then we can use Elixir's before compile hook and say, after you run through, generate each route, or accumulate each tuple, we're going to invoke a before compile hook and actually do a lot of code generation. So we'll basically go through a list of routes that we push on with the add route method, and we'll generate a match function and as well as a named route function if you've cast it with an as option. And a neat trick in Elixir is that if you're doing macro definition and you're like, what does this code actually look like that I'm producing? Because we're writing code that writes code, which can kind of be mind-bending. A way you can cheat, if you hop into def match, we can actually just store this as a variable. So I can say this is going to give me back some kind of abstract syntax tree. And I can just, at compile time, say, oops, convert that macro to a string, and then return it. And this will just let me know like what is actually happening. So if I trigger a compile here, work. So at compile time, we can actually see what the route code generation is actually doing. So let me single out one of our routes here. So when I say get to pages page, it's actually going to generate a definition, function definition called match. So all of your route, the entire route DSL basically compiles to dozens of match definitions. So at the end of the day, when your router is compiled, it's just going to have a bunch of match definitions, all with a unique signature that are pattern matching on the route that you defined. So when I say get to pages page, it literally is going to define a function called match. It's going to get a connection from the plug middleware. It's going to pattern match on the request type, which is going to be get request in this case. And then the request path is actually just going to be a pattern match list of strings split by either a / or a hyphen from the URL. But if you notice, we're actually injecting a page binding as the second argument to our path, because by convention we can say get to pages / page. We want page to be a named argument of that path. So we don't want to just solely match on the string page. We actually want that to be bound to a variable, and then we want to inject that into our params hash. So when this generates the def match for us, we're going to say that second thing, please bind that to a variable, name it page. And then the next line is actually just merging in any other parameters from the WebDriver with a key value page bound to the actual value of the matched page variable. And then we simply just call the controller action, show, and then pass in the connection, which has our new parameters. So we can actually run this just to prove that it works and say mix run, start my router for me, stay up and running, and include any dependencies. So Split. So we're showing page hello. So basically the parameter at the end gets matched and bound. If you look at that controller, we have a controller pages. We call it a show action, and we're literally just printing the page parameter that we're pulling off the connection. So connection is basically what the plug middleware gives us a direct connection to the WebDriver, and it has a few abstractions like params will be a keyword list of arguments, and we have injected page to be the thing that was pattern matched at the end of the URL as a named parameter. So that's essentially what's happening at the high level of the router. And the neat thing is all these things get compiled into just a bunch of function definitions. So the goal of all this is, one, exploit macros to our benefit, but don't generate insane code that you couldn't write yourself. Because the first rule of macros is to not write macros. But I love macros, so I want to use them where they make sense. But I also want to generate code that is simple enough that if someone wanted to actually define this themselves and not rely on macros, they could. So if we hop back into our router, we could literally define a manual match function. Maybe this is like, we want to do a get to blog post slash post. Oops. So maybe post will be the name of the post, and we want to inject into our parameters the post key with the value of the thing we're matching. Instead of calling the show action, maybe we call a blog post action. This isn't very restful, but just to prove the point that this is all the macro is doing is basically defining these 3 lines for us. So if I go back into my pages controller, I rehearsed this earlier, so pretend I typed this out, blog post. All we do is we get a connection, and we ask the connection parameters for the post variable that we kind of injected in there. I do need to restart. Code reloading isn't in place yet, so you have to recompile and restart the app. I hope to have that done sometime soon. So this should continue to work. But now, off of our manual definition, we could say blog post slash today, my post for today. Hey, and it called that controller action. So the important thing to realize with the router is every get, post, put resources macro that you call is ultimately defining a function called match with a unique signature that's pattern matching on the request path split by /. So if you're with me on that, I'll show you the actually nitty-gritty details of how that macro is expanded. The important thing to realize is ultimately under this hood, that get pages page is going to compile to something that looks nearly identical to this, just injecting the first part of the pages as the pattern match element of the list, and then the second argument would be a name parameter, variable page.
So Greg has a question.
Sure.
Is there a reason to prefer binary string param key instead of atoms?
Yes. So similar to Ruby, I prefer atoms, but similar to Ruby, the symbol table, atom table in Erlang is not infinite. So that will grow and basically consume all memory. There is a specific number of atoms that the Erlang VM can handle. I forget the actual count. So that connection.params is actually going to be any parameter that you pass in is like question mark, foo, bar, and bar baz. It will actually contain all those. So if we converted everything passed in from the URL as a atom key, someone could just basically hit our web app with ever incrementing random parameters and fill up memory of the atom table. So just like in Ruby, we can't just call like toAtom or toSymbol on user provided input. Otherwise, that could leave us vulnerable. So unfortunately, in this case, we do have to rely on strings for parameters. But that's essentially why. So just like Rails, if you're familiar with Rails, this actually landed just a few days ago. We added resources-based routing, and they support nested context. So if you're familiar with Rails, if I say like resources users, it's going to map out a bunch of RESTful routes. So it's going to map out like get to users / colon ID to like a controller user show action. Get to just users / would be like the controller's index action. All these like repetitive type RESTful endpoints resources is basically going to map that out for you. And it nests. So initially on the issue channel, I actually resisted even trying to go with nested routing because I thought that the macro expansion would be absolutely insane, because at compile time we actually would have to infinitely expand a macro within a macro, which is like really mind-bending to think about. But it turned out not to be too bad. So we get nested routing for free. And the neat thing is we have a mixed route that I have a core contributor, Darko. He's the co-founder of Semaphore app. He's provided some pretty awesome mixed tasks. So if you're ever coding your app and you don't want to try to reason about what these macros are generating, you can say mix Phoenix routes, pass it a router or a module that you've defined. We've named ours def module router, so we're going to pass in that name here. And my text is too giant to show this, but let me see if I can. Okay. There we go. So similar to Rails, I can say rake routes. We already have this. So this is super helpful to say these are literally all the generated routes that I have defined with their name parameters. So by saying resources, users, resources, comments, it's going to generate some nested routing for me with all the name parameters set up automatically. So we could actually say like router.userComments path, similar to Rails. I'll show how this works. It's kind of nice. I have a router that I've defined. I'm running IEX in the context of the application currently. So we have a router. We can actually see that we've defined some named route helpers. So I can say like user comment path. Oops. User ID 1, comment ID 2. And that's going to generate the path for us based on the alias that we have defined automatically. So by saying resources users, we get the named routes for free. And we should have like a page path. So we manually cast like a get to pages page as page. So that gives us a page path. And then I can just pass in the named arguments as key values, as a keyword list. So the page will be maybe home. And this is going to generate pages home. So that's super helpful. And then we can go into the details of macros. Do you have any other questions? Or are we good on that? I don't want to go like 1,000 miles an hour, but
no.
Okay. The biggest takeaway, I know I've kept saying that we're letting the VM do all the work on pattern matching the routes. Biggest takeaway is that is extremely performant, especially if you notice we support splats. So I can say get to files, asterisk path, and it's going to say anything after the / of a route that comes in, I want to pattern match that as a named param. Initially, I didn't think this was possible, but if you remember, we can pattern match on lists with head tail. So essentially what that's doing, it's not mapping out, oops, I'll just bring up the recompiled list, it'll be a little easier. Okay, you can go ahead and open that. Excuse me. All right, so the cool thing with splats is we can still rely on pattern matching by the VM. So if I said get to files and then anything after a files / I want to cast that as a variable, we literally use like the pipe for head-tail pattern matching, which ends up being pretty neat. So like all we're doing for splat matching is instead of mapping out a comma here, we can say anything after this element is just another linked list, which happens to be the split path of everything else that the WebDriver gave us.
So it's not a binary pattern match on the path?
No, it is. I'll show you.
Earlier?
I'll show you. I'll fire up IEX. So literally, the argument there is going to match on a bunch of binaries, but it's going to inject the like files path. Path will be injected as a bound variable. So like anything within that. So basically, essentially in the code, if we imagine we have some string from the WebDriver saying someone just hit files/users Chris docs cat.jpg. First thing we're going to do is we're going to split that. It's like under the hood, it's basically splitting that. It's a little more sophisticated, but for now, it's splitting that string by /. So this list is actually what gets passed to that function. So if we have def match files up here, that list is actually what gets passed directly into that parameter. But we're able to pattern match. So the function definition is actually saying pattern match on the first string files, but then use head tail pattern matching and say I want the rest of the path, and just please bind it to a variable for me. So if I set that equal to my split path, literally the VM is going to pattern match this for us and do all the work to say that matches. So now if I check out path, I have the rest of that path. And then we take one more step. If I scroll up here and find this, it's scrolling off the screen here. We take one more step and actually call a join on that. So instead of just passing in the bound value, we don't want to pass in an arbitrary list. We're going to recombine that for the user. So ultimately, that's essentially just calling path.join. So when you call your controller action, you get that whole string passed back to you. All with pattern matching, all done by the VM, and super highly performant, which is always nice. So we can get into kind of the grittier details. Now that you've seen the way that we can manually define a route, you can kind of see what's happening with this def match macro. Because all it's doing is it's going to use another module to generate some AST bindings, but essentially, if you ignore these quotes and unquotes, quotes are a way for us to inject code back into the calling context. Unquote is kind of like string interpolation for code. So when we say quote, we want to say, here's some code representation, and anywhere you want to inject your own code, you would call unquote, almost like interpolating a string. So just like we define our manual route in our router, here's a way we could manually define routes. The def match macro for each of these is going to look almost identical to that. So we're going to say define a function named match, pass in the HTTP method from the driver, and then the trickiest part is pass in some path arguments that are going to be specifically pattern matched on the pattern that you defined up in your userland router code. So that's probably the most complex piece of the code happens generating that. That's why I named this super explicitly. So if we call path, give me the matched arg list with AST bindings. AST is like the abstract syntax tree of Elixir. So literally give me the internal code representation of whatever that pattern match would be, is what I'm asking for that. And hopefully I'll be able to explain how that works. So this is the path module that we're asking for the match arg list with AST bindings. So if you imagine we're passing in something the user has provided us, like please give me, if I pass in a string users, named argument user ID, comments, named argument ID, I want that to actually turn into a pattern match code representation of what the VM should be looking for. So it looks like this really crazy looking thing here, but essentially all it's doing is saying, here's a list for you. The first element would be users. Oh, but you've injected a named argument. So this var bang here is actually an internal way for us to tell within the abstract syntax tree to say we have a variable. So instead of matching on the string user ID, we actually want to have a variable named user ID bound to whatever was in that second spot in the list, and as well as ID next. And if you just give it a string pages, it's just going to return you just pattern match on a list, one element pages. And the code to actually do this isn't too bad. It's about 18 lines. So people are wary of macros because they get really complex, but the amount of code that you can see on the screen here, we're taking user-provided string. So something like this user-provided string with named parameters. In 18 lines of code, we're converting that to basically something that can be pattern matched against in a match definition. which isn't too bad. So we'll walk through this because this is the key part of how the router works. So if you can grasp this, this is actually be really helpful to understand how macros are working and kind of get the magic of what's going on. So we start with a path, which is just going to be whatever the user gave us, like users slash pound or colon user ID. We're going to make sure that doesn't have a leading slash because that's going to ruin our pattern match. So we just want to, if the user provides us a leading slash, we're just going to ignore it. We're going to split it. We're going to split it by / and hyphen. So we end up with a list of strings split by /. We chunk it by 2. So we take that list and we just create two elements each. And this basically lets us peer into the list and say, what's the current thing I'm matching and what's the next thing that you're about to match up. And then we pad with nil if it's uneven. And then we go through each of those parts, and we chunked it because we want to say, what was that current piece of the path that we're matching, and what is the next part? Because if you gave us a named argument followed by a splat, we actually need to turn that into a head-tail AST representation. If you pass us just a named argument followed by a string, then we need to pass that through as just a list with named argument, comma, string. So we chunk it, that way we can peer in to say what's the next thing. And at the end, we just make sure we don't have any nil parts that we matched. So here's where we get into we're literally, instead of writing Elixir code with quotes, we're literally injecting the AST directly into the code, which you can do with macros. So macros don't always have to generate just straight Elixir code. We can actually literally pass in the AST back for cases like this. I wouldn't do this too often, but this is the best way to do this here. I'd love to be proved wrong, though. So this part to AST binding is going to be called for each chunk of the path. And we have a bunch of definitions of the same name because we want to pattern match on what's the current part and what's the next part. So if you notice, if you pass in a splat followed by nil, we know that we're done matching. And if you pass in, I think, Ryan, here's what you mentioned, we're doing a binary pattern match here. So if that chunk of the list, in this case, if you pass in users and then /: user ID, we can do a binary pattern match and say, do I have a string that starts with a colon? Well, the rest of that thing is going to be the parameter name. And if the next thing we're trying to match starts with an asterisk, we know we have a splat name. So if I get a named argument followed by a splat, I need to return an AST that says, you notice this pipe here. If you do head-tail pattern matching in Elixir, this is exactly what the AST looks like. We're going to say we're going to return a head-tail pattern match and bind the variable user ID, or our user example in the documentation didn't contain a splat. But we're going to bind a variable with whatever parameter name of a named argument followed by the splat name. And then hop into the next. That doesn't match. We're going to say, well, if you start, the current thing we're matching is a parameter, starts with a colon. It's a parameter name. And followed by anything else, we know that we just need to bind a variable to that. And that would be if we wanted to match like pages /page. We just know that if you give us a name parameter, instead of matching on a string, we want to return the AST of a variable definition. Is all it does. That's that var bang thing that you saw. So var AST is just a little helper method that's returning a Elixir-ism for a variable definition. Give me the AST for a variable definition. And then the last part of it is if you give me a string part followed by a splat, then instead of casting a head-tail match on two variables, I just need to cast a head-tail match on the string part followed by a bound splat name. And if you give me anything else, I know it's just a string, return the string. So does that make sense for everybody? Because this is basically the meat of generating the different pattern matching type options for the router. So that's what lets us basically operate at a higher level here and say that if you provided a splat here, it's going to return the AST representation for binding path to a splat instead of a single variable.
Is this going to be the extension point for where you handle like query params and stuff like that?
Query params you get for free from, we're using Plug, which is it lives under the Elixirling repo. And Plug is basically a abstraction. It only supports Cowboy right now, if you heard of the Cowboy WebDriver, but plug is a way. Plug basically gives us a connection to a WebDriver, and we can say connection.parameters, and it will return us any arbitrary query string parameters already split out into a keyword list. So that's where, if you notice, my match gets in conn gets injected here. That's from the plug library, and connection.params returns you a keyword list of parameters that are already, the query strings are already split out into keyword lists for you. And that's why I just merge in any name parameters on top of that, and then call the controller. And that actually happens in router. So when I say use phoenix.router, it's going to first use phoenix.mapper, which is all that macro generation we saw. And then it's going to basically define a start method on the router for you. And this is where plug comes in. Plug basically says, hey, I'm running the Cowboy web server underneath. Please inject these options for me. And then start a server. And the plug convention is your module has to define a call. So I have a call method defined, and I fetch all the parameters for plug. I split the path here so we can pattern match on it. And here's some debug code, but ultimately I'm dispatching. I have a route, and I want to dispatch it to a controller. So that's what I call dispatch. And that starts a little gen server and tries to run the request. Plug is very similar to rack, yeah. Synonymous with rack, I would say, for Elixir. Except there's currently a lot of discussion on where how we want to implement middleware with plug, because rack basically requires you to write. You basically have to wrap the entire connection. And the goal right now, there's a lot of discussion around it, but I would like to see plug basically using a plug for anything. So if you're familiar with Rails like before filter, I'd like to see that to be a plug middleware. Instead of wrapping the entire connection, I'd like it to just say, do something with the connection before you run my call method, instead of trying to wrap the whole thing.
You want plug to be the wrapper?
No, I want plug to be a wrapper, like in this case when it needs to. I also want plug to be also like a before filter, if that makes sense. Because the only convention in plug right now is it has to return either OK in the connection that we may or may not have modified, or halt in the connection, where it means don't continue. So I'd love to see where our answer to everything is, how do I do X? It's like, oh, I'll put in a plug. And that plug could wrap the entire connection, or that plug could just say, does user authenticated yet? Okay, return OK connection, otherwise return halt unauthorized. If that makes any sense. But there's no, that's just at discussion level right now. So all plug is right now is it calls a call method, passing in the connection, which is like a direct reference to the WebDriver. And we're using that in Phoenix's controller. So when we define controllers, ultimately that's using we're using Phoenix controller, which is just a very slight layer providing some conveniences, like text. Defines a text function, provides a redirect function, and I'll open that up. So there's not really any magic in controller at the moment. I want to provide some magic a little later, but all the controller is, it's basically defines some convenience methods for you. So if I want to render some HTML, I can just say HTML. It's going to set the response text HTML for me properly, and then render it. So ultimately, this is like a plug convention. So if you notice, our controller eventually returns a plug, which is going to return OK connection. So it's going to say, hey, put the response content type, and this is all part of plug right here. And send response is basically send this directly to the underlying web server to send back to the client. So plug is an abstraction on top of that, where it's only Cowboy supported right now. Oh, that's great. Okay. I'm running ScreenFlow underneath, so it's filling up my hard drive. It's okay. Hopefully, as long as it doesn't crash. And the redirect's very similar. Redirect, I'm just putting a response header, location, the URL you gave us, and then if you're running like a 1994 browser, we render HTML and say, hey, this page has moved. And there's also a not found and an error. So you write bad controller code and it blows up, you will get a unstyled internal server error message, but that does exist, at least. And the not found is kind of cool too. If you notice, go back into Mapper somewhere. here we go. So when we go through, this is back in our route mapper. When we're generating all your routes, doing all this code generation, at the very end, first thing we do is we say, give me the route AST. So define all those methods and store it in a variable. So route AST is going to have all of those defined routes. And then the thing I inject back into the caller is a convenience method for printing out routes. And then I basically inject all of those defined routes. And then the next important thing is I define a catch-all match. That's going to say if you get this far, this is going to match anything because all of our routes are just named match. And it's just going to call controller not found, which renders 404. So basically a very solid throw. We just have match, 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 match. Nothing gets triggered. This catch-all is going to be defined last in our module. And controller not found just sends a 404 response right here. So the goal right now is exploit macros where they make sense, but make the code generation hopefully straightforward enough that we can follow it. So I have a resources macro that I mentioned earlier, and this is quite a bit of code generation, but ultimately this macro is basically just proxying to our other macros. And it's just basically very straightforward. It's going to go through and define all those RESTful endpoints using the existing macros that we have. But the only tricky part is we support nested resources. So this is mind bending, even though like I wrote it, even thinking about it now. You notice we're yanking out a do. So everything in Elixir is really just a sugar for like a keyword list. So when I say resources users do in, that do is actually just a keyword list argument with do as a key. So I can get the nested route. So if I said resources, oops, let's go into that. So here, if I said resources users do, do is actually going to be a keyword list. I can pull that out and get the internal code within that. And I want to grab that out here as a nested route and say, hold on to that. Don't do that. Don't do anything with that yet. So my first level of resources user is going to come through and say, okay, grab a nested route off if you have one. Generate all these functions for user. And then basically I have to push a context of my current nested level, inject the nested route, and then pop a context of my current nest level. And hopefully that's straightforward enough, but what's happening on these three lines is resources users, when nested route expands, it's going to say resources comments, which is going to call this macro again, right? So basically these three lines are infinitely expanding macros. Basically, as it goes, it's going to push and pop the context that it's at and generate code. So if I said resources comments, and then within here, resources files, I can go on down infinitely, and we're basically going to push and pop that current nested context and inject the nested route, infinitely regressing, basically.
It's all compile time.
All compile time, yeah. So the biggest thing to realize, Elixir is a compiled language, so we are doing all this work just at compile time, and when compile time is done, we end up with a router with just dozens of match functions. And the VM does all the work from there. So at the very end of it, all of our router matching code is done. We're not actually doing anything at runtime to match routes. VM is doing 100% of that. We've just defined functions, which is kind of neat.
Yeah. So
you don't pay any performance penalty for all this code you see here. This is all just during compile time. So that's basically the router, and I'd say it's shaping up pretty nicely. We don't want to replicate Rails entirely, but it will look very familiar if you're coming from Rails. The next thing is I'm looking at Django. Django specifically injects your name parameters as function arguments in your controller, which would be kind of cool. So if we open up a controller example that we have, this isn't in place yet, but I'd like to experiment with, if users show as a resource route, I'd like to see like an ID there of the named parameter passed in. And if we have nested, like comments was nested under resources users, I'd like to see for showing a comment, I'd like to see user ID and the comment ID injected So we don't have to constantly, like in Rails, otherwise we're constantly reaching into connection params, user ID.